Hello, 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 and welcome back to Shikshah DaCosta. Today we are going to review our unit on applying probability. So today we are going to review what we learned in this unit. In this unit we learned to determine and represent probability and to identify and interpret how we would apply it to real life. How do you know that you were successful in this unit? Well, ask yourself these questions. Are you able to identify examples of the use of probability in the media and the ways that it's represented? Are you able to determine the theoretical probability of something happening? And are you able to represent that in all sorts of different ways? Are you able to perform probability experiments, representing those results using a frequency distribution? And are you able to use that to determine what is the experimental probability of an event? And then, did you compare, using an investigation, the theoretical probability and the experimental probability? Are you able to explain why those two are different? Did you determine through an investigation using technology-based simulation models, so in a way that doesn't have to have us make our own probability experiment results by hand, instead we use a simulation model like a computer, are you able to determine that the tendency of experimental probability is that it approaches theoretical probability as you increase the number of trials? Did we do that? And I think we did. And finally, are you able to interpret the information that involves using probability and statistics as they're shown to you in the media? And are you able to make connections between those two ideas? If you're able to do all of these things, then I would consider this unit a huge success for you. The first thing that we did, in case you did end up forgetting some of those things, the first thing that we did in this unit is we looked at theoretical probability. You can calculate that, the theoretical probability of something that has multiple trials by using a tree diagram. And we really went into a lot of detail on how to make those tree diagrams. What is theoretical probability? It's a way to measure how likely an event is to happen. And the way we calculate it is we take the number of successful outcomes, whatever a success means to you, and you divide it by the number of total possible outcomes. And that is how likely that event is. This will usually be a value between 0 and 1 if we're representing it using a decimal, or between 0% and 100% once we divide these and then multiply by 100 if we're expressing it as a percentage. If there are several events that we are checking, we can find out the theoretical probability of each of them and then add those together to find the probability of one of those events happening. If you want to find the total outcomes, the total number of outcomes, if there are many steps, you just multiply the number of outcomes in each step. So if you're rolling a 4-sided dice and then a 6-sided dice, the first step is the 4-sided dice. There are 4 outcomes. The next step is the 6-sided dice, and there are 6 outcomes. 4 times 6 is 24. That means there are going to be 24 total outcomes. And finally, remember that something called the complement of an event is the likelihood that the event will not happen. And that's super easy to calculate. All you have to do is take 100% and subtract the percentage of the event itself. So if there's a 10% chance that you will win a raffle, there is a 90% chance that you will not. 100% minus 10 is 90. Okay, so you just subtract your event's probability from 1 if you've expressed it as a decimal, or from 100% if you've expressed it as a percentage. From then, we moved on to actually doing probability experiments. Experimental probability is the likelihood that an event will happen, and that's the same thing as theoretical probability, you might say. But this is actually the difference is the way it's determined. Theoretical probability is determined by examining all the outcomes, but experimental probability is determined by how often that event has already happened in your experiment. So you can conduct that experiment to find out, to make certain what is the frequency of each outcome, and then use that to calculate the probability of future trials based on that data. If you increase the number of trials, you increase your accuracy. And very similar to data science, when you increase the sample that you take, the size of the sample, it makes it represent the population more. Just think of, students in school. If you sample one class and try to apply that idea to the whole school, your data might be biased. But if you sample 10 or 15 classes, then your data becomes more and more representative of all of the students in the school. Experimental probability is very, very useful, even though it's not as accurate as theoretical probability, because not every situation has a theoretical probability that we can calculate. Some of them you just have to be like, okay, this is the data I have. I don't know all of the possible outcomes, but this is what's happened so far. And so experimental probability is also super useful. But to really make use of it, we have to understand its relationship with theoretical probability. And that's exactly what we did in our next lesson. We compared those two things. And we noticed that the more trials we do in an experiment, the more we can rely on that data to actually be accurate. And as we saw, the theoretical probability is the most accurate data that we could get. And many, many, many trials make the experimental probability get closer and closer and closer. In other words, it approaches the theoretical probability. To simulate this, we can use the formula rand between on a spreadsheet. And we can simulate stuff like dice rolls or spinners or whatever, just choosing a random outcome between any number of outcomes. This function is super, super helpful. And then when we've generated a bunch of data by copying this function between many, many cells, we can use the COUNTIF function to create a frequency table. And that way we don't have to count the data ourselves. We can just have a computer do that work for us. So between these two, it'd be super easy for you to simulate a probability experiment. Finally, we learned about statistics and probability. And here we learned that statistics are related very closely to probability. Just as probability experiments help us to find out, what is the experimental probability, and then we can use that to predict what's going to happen in the future, statistics are used to predict future events. So in this way, we can look at statistical data and be like, this is like somebody already did this experiment a bunch of times. And we can collect that data from real-world events and information, and then we can use that data to actually predict future events. Sometimes the media will do this, but what they will try to do is they will sensationalize what's happening. They will misuse probability and statistics to try and make it seem like, oh my God, this is amazing, or this is so terrifying, because it's trying to get a stronger reaction from you. The more you react to it, the more upset or the more happy it makes you, the more likely you are to be engaged. You'll put some comments in the section like, haha, LOL, this was so great. Or you'll be like, this was crazy, it's so wrong. What they're trying to do is just get you to engage. Because the more you engage, the more they get paid from their advertisers. Because their advertisers are saying, hey, people are spending time on this website. Which means their eyeballs are going to see my product more and more and more. And so we have to be really careful whenever we do anything on the internet or in the news, whenever if we're reading a newspaper or anything like that, or watching TV, we always have to be really, really careful whenever we see statistics because the media has a tendency to make those sensationalized. It's our responsibility to know about statistics and probability so that we don't get misinformed. A strong basis of knowledge and critical thinking skills about probability can help us avoid that misinformation. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.